This is after lunch, so McDonald's will just make you feel a little craving, not totally starved the way they were when we did this right before lunch. What we're going to do today is we're talking about the distributive property. So to help you understand this, we're going to talk about combo meals. Here's why this is important. Your parents could probably empathize with this a little more, but there are so many times I've gone through the drive-thru and ordered a couple combo meals, got home and realized they messed up my order. So by understanding distributive property, you can actually save yourself because you can check your order before you even leave and make sure you have what you're supposed to have. I will say, just to call them out, Popeyes here on base is like the worst, especially since they changed their condiments policy. I really like the shrimp, but I have to have cocktail sauce with it. And I've even asked for the cocktail sauce, and they still didn't put it in the bag. But by the time you get home, I'm not coming all the way back on base just to get that. So what I'm saying is, what we're teaching you today can actually have real-life application, as you'll see in the combo meals, to make sure you get your orders correct. Now, we're going to just call this, for ease of use, combo 1 is our fry lover meals. I don't know how many of you have had the McDonald's fries here on Japan. Their oil is amazing. So my first order of fries is basically gone before I even get home because I eat it as I'm driving. So I need that second order of fries just so I have something to eat with the hamburger. Our second one is our thirsty meal. We got 2 drinks with the chicken nuggets. Number 3 is our big guy meal. He's got 2 Big Macs and 2 drinks. And number 4 is what I call our kitty combo. We got all the chicken nuggets with plenty of drink for them as well. So our first one we're going to do is we're going to buy 2 of combo meal number 1, please. So how much food is that? What we do is we have 2 combos. Each combo has 1 burger, 2 fries, and 1 drink. Does everybody see that? So we're making sense so far? Yes. So mathematically what we're going to do, I'm going to distribute the 2 to each item by drawing an arrow. So I go the 2 times the 1 burger, 2 times the 2 fries, 2 times the 1 drink. You guys should be writing this on your paper, not having your head down, Keelan. So 2 times the 1 burger means I end up with how many burgers? 2. 2 burgers. 2 of the 2 fries means I end up with 4 fries. 2 times the 1 drink means I end up with 2 drinks. So with 2 combo meal number 1s, what I actually bought was 2 burgers, 4 fries, and 2 drinks. Does that make sense to everybody? Yes. Okay, let's do another one. Now I'm going to buy 3 of combo meal number 2, please. So what number is going to go out here? How many did I buy? 3. 3. So I'm going to put a 3 out here because I bought 3 of the combo meals.
Wait, oh yeah, number 2.
Okay, now we're doing the combo meal number 2. What was included in that?
So one chicken nugget.
1 nugget.
1 fry.
1 fry. 2 drinks. Okay, so now we're just going to use the numbers so we can do the math piece of this. I have 1, 1, and 2. I'm going to distribute the 3 to each of those inside terms. So 3 times 1 nugget gives me how many nuggets?
3.
3. 3 times 1 fry gives me how many fries? 3 times 1? 3. 3 times 2 drinks gives me 6 drinks. So what did I end up buying on this one? I bought 3 nuggets, 3 fries, and 6 drinks. Everybody tracking on this so far? Okay, let's do another set. Now we're going to do 2 of combo meal number 3. So where does that 2 go? Showing we're buying 2 sets of the meals.
The outside.
On the outside, because I have 2 of those whole meals, right? What's included in combo meal number 3?
2 Big Macs.
2 burgers.
1 fry. 2 drinks.
Everybody see that? Okay, so let's rewrite this mathematically. We've got 2 with 2, 1, and 2 on the insides. So I'm now going to distribute that 2 to each of those inside terms. So 2 times the 2 burgers gives me 4 burgers. 2 times the 1 drink gives me 2 drinks, I'm sorry, that was the fries.
Fries.
2 fries, and then 2 times the 2 drinks gets me 4 drinks. So what is it I ended up buying?
4 burgers.
4 burgers.
2 fries.
2 fries.
And 4 drinks.
And 4 drinks.
Wait. Oh, it doesn't have like the lines anymore.
Nope, doesn't have the lines anymore. So now we're just saying, can you do this? So now I'm going to buy 3 of combo meal number 4. So where does that 3 go?
So in the outside?
On the outside. And then the parentheses, what does combo meal number 4 have?
2 chicken nuggets.
2 nuggets, 1 fry, and 2 drinks. So let's rewrite this so we can do it mathematically. 3, 2, 1, and 2. And I'm going to distribute the 3 to each of those inside terms. So 3 times the 2 nuggets gets me 6 nuggets. 3 times the 1 fry gives me 3 fries. And 3 times the 2 drinks gives me 6 drinks.
So we buy
So what did we buy on this one?
6 nuggets, 3 fries.
It's like number 1 except that 3 more nuggets.
It is very close to number 1. And then our final one. Now we're going to go back. We got hungry. We're going to buy 3 of that combo meal number 1 instead of just 2. So what was combo meal number 1? That's our fry lover. So we have a burger, 2 fries, and a drink. So mathematically, we're doing 3 times the 1, 2, 1. Distribute my 3 to each of those. Gives me 3 burgers, 6 fries, and 3 drinks. So I just wrote the answer out there instead of rewriting it. Just for the record, that's a 6 in front of the fries. I'll rewrite that.
So 3D plus
3B, 6F, 3D. So 3 burgers, 6 fries, and 3 drinks. It's just making sense, guys. You understand what we're doing? Okay. So by putting in terms of the combo meals, the idea was to get you so bought in that this is actually relatively easy to do. So now let's actually talk about the mathematics behind this. So what does it mean to distribute? Distribute means what? Now we're testing your English skills.
Wait, is it like taken away?
No?
Wait.
Logan? Give out. So distribute is giving it out, right? So distribute means give out. When using distributive property, we give out the number or the variable on the, which side of the parentheses was the number that was being given out? Great, I'm glad you said outside and not on the left. Because what you'll see is it can be on either the left or right. The key is it's the one that's outside of the parentheses. And then I'm giving that to every term on the inside. Okay? We use distributive property to find the total value. One of the big keys on distributive property, and we're going to get some practice on this, is distributive property is actually really good for doing mental math. Because what we can do is we can break a more complex number down into pieces that are easier to manipulate mathematically, so we can actually do it in our head. Okay? It is useful when we need to multiply a group of blank being added or subtracted. I don't think we've actually used this, but it's not just numbers, it could also be variables. So because we're talking numbers or variables, the mathematical word for that is terms. Okay? So the terms being added or subtracted together, what we're doing is basically breaking them down to make them easier to do. So here's an example of distributive property with addition. Go ahead, Jackson. It's already down there.
No, it's on my.
Okay, first thing we do is distribute using arrows. So I'm going to put arrows from my outside number to the inside ones. Go ahead, Noah.
Okay, so 2 times 5.
So then I'm going to rewrite that. That's now 2 times 5 plus, and that's only because that's a plus sign there, so whatever sign that is goes down. And you'll see this, it works with addition or subtraction. 2 times my other quantity, which is 3x. So then I can actually do the math. What's 2 times 5? 10. What's 2 times 3x? 6x. Can I simplify any further? When we say simplify further, that's basically talking if we had fractions or something, where you were able to simplify further. But in this one, we can't. Due to time, we're not going to worry about the model. Okay, so here is how you distribute. Step 1, use the arrows. Step 2, actually multiply. Step 3, simplify if needed. So in addition, all we're doing, write the arrows in, rewrite my term, so it's going to be 2 times 5. Whatever is on the inside just comes straight down. In this case, it's a plus. 2 times 3x. So 2 times 5 is 10, plus 2 times 3x is 6x. Nope, you can't combine it without when I don't have a term with 1.
So you can only combine if you don't have a variable.
Correct. Because it said to.
Can we do the other problem on our own?
So, guys, for those of you in here, Manny asked, why are we doing plus? Manny, it's because there's a plus right there. They told me to. That's why we're doing plus.
No, 2. Like, why does it say 5 plus 2 and 3x?
It says 2 times 5 plus 2 times 3x.
That's order of operations.
Order of operations, I have to multiply before I add. What, the order of operations doesn't make any sense?
You can't put 5 and 3x together because 5 doesn't have an x. If they don't have the same variable, they don't go together.
Manny, if you can only combine them if they don't have a variable.
Or if they have the same variable.
Oh yeah.
We'll get some more work on this in a little bit. So using subtraction, it's the same concept. I distribute using my arrows. I rewrite it, 3 times x. The only thing that changes is now it's a minus. So I'm going to subtract 3 times 4. Now I combine my terms. 3 times x gives me 3x minus 3 times 4 gives me 12. I can't simplify any further. There's my answer.
Do the other ones on our own.
Do what?
Do the other ones.
Tim,
Oh, I thought you were talking to me. I was like, what'd I do?
no, he looked at me and said, can I have a cookie?
I want a cookie.
No cookies for you, Logan. Okay, we're going to give you guys a chance to practice this. We've already spent the last 15 minutes doing this.
Look it up, or no? Or is that how you lost it
That's
last
how I
time?
lost it last time.
Not touching it.
Okay, so we're going to give you guys a chance to practice on your own. You can work as a table if you want to. I'm going quick because we're running out of time and you should already have the answers.
Yeah.
So, first one should have been really simple. 6 times x plus 6 times 5 gives us 6x plus 30.
Yeah.
Second one should have also been relatively simple. The only snag here was they threw a minus in there. So 2 times r minus 2 times 4 gives us 2r minus 8. Third one, another really simple one. 4 times x plus 4 times 8. The only one there is there's still several of you who don't know your 8 facts, but that's 32. Now, this is where they threw you a little curveball. Now, I'm coming from the right. My arrows do the same thing, though. So n times n
N squared.
plus 6, n times 6, sorry. Because the n's on the outside. So when I rewrite that one,
N squared.
yes, good job, Seamus. N squared. Do I do n times 6?
N
6n, my coefficient always comes first. Now, I think it was actually Damien asked a great question. He said, if it makes me feel better, can't I just rewrite that on this side? Honestly, you can. It doesn't make a difference. You'll have the exact same thing. So if you actually feel better doing that, I don't have a problem with it. Mr. McShann, I didn't talk to you about that. You're good? So for both of us feel that's absolutely fine. You can rewrite that one that way if you want to. Okay, our next one. The only difficulty here is now they've added a coefficient in front of the variable, but the process is still exactly the same. So 7 times 2x gives us 14x. 7 times 10 is 70. Same thing on this one. They've added a coefficient to the variable, but it really doesn't change anything. It just means 8 times 7x gets me 56x minus 16. And here they put the variable second instead of first. But again, it really doesn't change anything. I literally just keep it in the order that they have written it, and then combine what I can. 15 minus 3y. And then the last one, again, they threw it on the wrong side, but it doesn't really change a thing. It's 8 times 2 minus 8 times n gives us 16 minus 8n. Questions? No?
I got it all right.
You didn't get it all right.
Yeah.
Nah.
Yeah.
I already made 2 corrections. I have plenty of witnesses. Go have a seat, Damien. Okay, so you guys can actually put that away, put that underneath your desk or underneath your binder for a minute.
Let's ask me to do the homework.
We'll talk about the homework in a minute. Right now, I need you to put that either underneath your desk or underneath your binder. Because we have the Nathans of the world that are going to sit there and try to do their homework instead of actually listening to what we're supposed to be doing. Yes, Nathan, put it under your desk. Thank you. Glad it only took a personal invitation. Now, you may want a blank piece of paper for this next piece. What we're going to be doing is several of these. There's a missing piece as we have rewritten this using distributive property. But in all cases, we are going to want to find the value using distributive property. So we're going to go back and forth about which way it works well. Damien, that needs to go away. Underneath your desk or underneath your binder. Yes?
Mr. Moore.
We'll come back to it in a minute. Under your desk.
Mr. Moore.
You may, we at least need to write down your answers, but most of you are going to want to rewrite it. So on the first one, what is the missing number? Seamus? 23. What's the actual value of this? The way I would solve it is I would actually do my combination first. 7 and 23 gives me 30. 8 times 30 gives me 240. Isn't that a lot easier than doing 8 times 7 and 8 times 23?
Wait, what?
Again, this is a big advantage to distributive property. We're able to manipulate our numbers to make it easier to do mental math. That's really one of the big purposes of distributive property. Jacob? We did find the value.
Mr. Moore.
Yes. For all these, we're going to find the value. That's why I said get out a piece of paper. Okay, our second one, distributive property. In other words, this one's already been distributed, so pull this back in to make it one term that you're going to add together, and then be able to solve for the value. Yes, Gabriel?
Since there's no variable in there, we can combine those, right?
Correct. That's where all these are going to be. That all of these just have values. There aren't any variables of what we're doing right now. Seamus? 50. So, using distributive property, now I'm going to actually pull the terms back in. 5 times the quantity 8 plus 2 gives me 5 times 10 or 50. This one, the numbers are easy enough. You could have done 40 plus 10 and gotten 50. But because it said use the distributive property, that's what it's saying. We did want you to pull it back in and see that I can do the 8 plus 2 instead. Okay? Starting to make sense on what we're doing? Good. Here's our third example. Now use distributive property to evaluate this one. So in other words, you're going to pull the 29 apart into pieces that are going to make this easier for you to do mentally.
So 8 times 2, 8 times 4. You said take them apart.
Yes, because 2 and 9 is 29.
Place value. Place value.
Face value matters.
Wait. Oh, oops, never mind. That didn't go to 11.
Yes.
Oops.
Just for the record, that was Gabriel.
I need your top.
Oh, I'm going to send her the link, personally. Okay, so how did you guys rewrite this one? Seamus?
I did 8 times 20 plus 8 times 9.
Good. That's what I would have expected most of you to do on this first one. So that gave us 160 and 72 for a grand total of 232. Did anybody else do it differently? Gabriel?
He did 8 times 2 plus 8
That's true. He did 8 times 2 plus 8 times 9. He did not, however, get 232 out of that. Now, I'll be honest. Here's the way I looked at this one. I said, oh, wait, 29, I can do 30 minus 1. So I can do 8 times 30 minus 8 times 1 gets me 240 minus 8 or 232. Why did I do it that way? Because I prefer using single digits where I can. So once I start getting to the upper numbers on the inside value, I'm going to subtract instead of add. Because 240 minus 8 for me is easier than 160 plus 72. Now in this case, both of those, neither one is overly hard, so either one is actually fully operational. But you get used to doing it both ways because it'll make your life easier. Okay, what's our missing number on number 4?
3.
Gabriel?
3.
3, good, because that was the number that was pulled out. So what's our value? 3 times 2.
And 4. And 6. Plus 8. Wait, no, minus 8.
What?
Wait, no. I counted it down.
Oh, Gabriel, you're just making this so enjoyable for today.
Oh my.
Okay, what's our missing number on this one?
30.
3, good. So to break this one down, 4 and 30 is 120. 4 times 3 is 12, gives us...
I can do now.
I'm not even doing any work.
We still have Star to go. It's Wednesday.
Wait, how long is it going to do this?
An hour.
If people free passes are going.
Okay, number 6.
I'm good.
Hey, this is a really good one for distributive property.
Oh, we gotta do the math.
My kids work really hard on this.
Oh, Miss Witt's helping on the other side. Yeah, right, Damien.
My kids work really hard on this one in A2 and I just laugh at them.
Because it's so easy.
It's you.
Who's got the answer?
I make them raise their hands.
What'd you get, Aiden? What? 40. Awesome. How did you get it?
I need light.
Guys, listen.
Listen, Aiden.
What did he say?
He said he forgot how he got the answer. So I'll help remind him. He pulled them back together and said 34 minus 24 is 10. 4 times 10 is 40.
Yeah, my A2 kids did 4 times 34.
Hey, this
4 times 34.
If what? No. Okay, number 7. What's our missing number?
6.
Nathan. 1. So that one is just 180 plus 6.
Look at my face.
See how easy that is? Bobby, I go so fast because it's easy. That's why we do the distributive property. We make these numbers easier for you. Number 8. What's our missing number? Keelan. 3. So we've already done this one. 3 times 2 gives us a 6.
Well, I just said right.
I don't know. Number 9.
I didn't think I noticed that my first in A2.
The first 3 times we've done it? So this is our 4th go-through on this, Miss McShan.
Miss McShan's like her too. We discussed this when I walked here.
174, how'd you get that? Okay? So he broke it into 50 plus 8, 150 plus 24, 174. This is another one. Personally, I probably would have gone 3 times 60 minus 3 times 2. Gives me 180 minus 6, 174, same answer. Different approach. Either one, fully good as long as your math is correct. Yes, Gabriel? In 3 more problems. Ooh, here's a good one. What about this one?
75 plus 300.
Which is? Jinx. Oh, Miss McShane can't talk. Yeah, Seamus. 375. Okay. Now, when they're saying use distributive, I think they were saying do 3 times 125. But I'll be honest, I would have done the broken up piece. Excuse me.
Michael, is that you talking?
Hey guys, please quiet down. Okay. We haven't done one this big, so let's see if you guys can figure out what's missing here. Abel. 90, good job. Someone said 9, I don't know who it was.
Somebody said 19.
They forgot the place value. So the nice thing on this, even a big hard number like this, when we break it down into these pieces, it's actually pretty easy to put all those pieces together, right? 788. Again, this is one personally I would have done 4 times 200 minus 4 times 3 gives me 800 minus 12. The only downside on that one is it is double-digit subtraction, but it's still not bad. And, yeah, good. Last one. Missing number is 30. Caden?
No, it's not 30.
I thought you was an 8.
Shayna, she's been going so hard today. Keelan? 36? Because 36 minus 2 is 38. Abel? 40. Thank you, Abel. Thank goodness we have Mr. Moorside to save the day on this one.
Your first one said 30.
Yeah, we're ignoring her this time. So, 200 minus 10 gives us 190.
No.
So, you guys seeing the advantage to distributed property?
Yes.
Okay, now you may pull your packets back out. Okay, on the homework. First part pretty easy. Guys, listen. Listen. Here's your help on the homework, guys. This first part pretty easy. Don't be confused when they throw it on the right side. It's the same thing. Remember, variable times variable we show as m squared. Okay? Don't be confused if it's all variables. All it is putting those together. Same thing here. Don't worry that we got different letters. That just means you're not going to be able to do any closer than that. On this one, here's the big one. Demonstrate 2 ways. Basically, we want to see the distributive property in both forms. Put it together with a quantity, and then break the quantities into 2 pieces. That's what we're saying. That goes for all 3 of these problems, so make sure you're demonstrating 2 ways to solve. The last page, really simple. You guys have gotten used to these mazes by now, hopefully. We did throw our lucky unicorn in to make it even easier for you. That is a unicorn. It has a horn. When's the last time you saw a pig with a horn? Audrey, come on now. Guys, listen. You're the cow. Quiet. Here's your work. Here's your work on this one, guys. Show me your arrows. 4 times 2x gives me 8x. Plus 4 times 1 gives me 4. Once I have my answer here, I find it on the side. That's the arrow I color in. And that's the next one I do. 3 times y, 3y. 3 times 2, 6. You just keep going around until you go past your lucky unicorn and then get to the finish down here. Seamus. Okay?
On problem 7, it says
Okay? Same thing. Distribute it. Distribute it to both. So we write it 1/2 times R minus 1/2 times 10. What's 1/2 times R?
That'll be 10 halves.
Somebody said it.
That'll be 10 halves and 1.
What's 1/2 R? It's 1/2 R. Minus what's half of 10?
Hi, Manny.
There, you've got a bonus answer. We haven't given that all today. Okay, guys, that's it.